In advanced science and technology, understanding how materials behave at very low temperatures is challenging. Picture a world where electricity flows without resistance, biological tissues can be preserved forever, and gases turn into liquids with unique properties. These are real phenomena enabled by cryogenics. However, turning these ideas into practical uses is very difficult. This challenge led us to visit the National Meteorology Institute of Malaysia, a leader in precision and innovation in measurement science. For future graduates interested in cryogenics, gaining hands-on experience is crucial. Participating in internships and training programs at cryogenics-focused lab or companies will provide invaluable practical skills. Engaging in research projects during your studies, particularly those focused on cryogenic materials development, will deepen your understanding and open up new opportunities. Additionally, staying updated on the latest technological and research developments through scientific journals, industry publications, and online resources is important. Keeping informed about advances in the field will help you stay ahead and adapt to new challenges and innovate.
On 30 May 2024, we visited the National Meteorology Institute of Malaysia. Starting at 10:30 a.m., we toured the Surface Analysis Lab, followed by the Blood Alcohol Content Lab, emphasizing precise measurement. In Block 7, we explored the Viscosity Lab and the Resistant Thermometry Lab, focusing on the liquid nitrogen calibration. Our final stop included the Radiation and Thermocouple Labs, essential for industry standard. After lunch, we attend a lecture and quiz session concluding with a dry ice calibration demonstration. We wrap up our visit at 5:30 p.m. and return to the University Technology Malaysia.
Okay, so next we move on to the result and discussion. Eventually, we proceed to the auditorium to observe the calibration measurement of cryoliquid demonstration. An experiment was conducted by testing unit under test consisting of PT100 under two distinct conditions with the standard reference. This experiment was set up by filling an insulating flask with dry ice, which maintained a temperature of approximately negative 79.65 degrees Celsius. And this setup provides a consistent low temperature environment ideal for this experiment, and the placement of PT100 sensors were set up under two different conditions, and the table shows different condition setup of PT100. The first condition is where PT100 sensors in direct contact with dry ice, and the result shows negative 78.65 degrees Celsius. This is maybe due to the thermal shock, condensation, and the fluctuating readings. And the second condition is where PT100 sensors is inside a tube within the flask, and the result shows negative 77.20 degrees Celsius. This is maybe due to the insulation effect of tube and moderated thermal response.
In our study, we observed that the PT100 sensor in direct contact with dry ice provided temperature reading closer to the standard reference compared to the PT100 placed inside a tube or with indirect contact. This difference is due to the higher thermal conductivity achieved through the direct contact. Direct contact allows for more efficient heat transfer, enabling the PT100 to obtain a more precise reading of the dry ice temperature. On the other hand, placing the PT100 inside a tube or indirectly can lead to variation due to environmental temperature fluctuation, affecting the accuracy of the measurement.
In conclusion, our academic trip to the National Meteorology Institute of Malaysia, or NMIM, provided us with invaluable practical insights into the world of cryogenics as well as low-temperature physics. The tours of different laboratories and engaging discussion with the experts enriched our understandings of cryogenic techniques, calibration methods, and the state-of-the-art measurement instruments. This experience seamlessly connected the theoretical studies from our previous lessons with the real-world applications, making the learning process more tangible and impactful. Throughout our visit, the dedication and expertise of NMIM professionals were clearly evident. Their commitment to upholding international standards and contributing to technological advancements was inspiring and highlighted the critical role of continuous learning and innovation in the field of cryogenics. Overall, this experience not only reinforced the theoretical knowledge we gained in the classroom, but also emphasized the importance of practical application and ongoing education in this dynamic field. Thank you for listening.